Hello all and welcome to the video on solving quadratic equations. Okay, so let's get into it. Let's do a do first together. So this problem says use the axis of symmetry, y-intercept, and vertex to graph f of x is equal to x squared plus 5x plus 6. Then identify the domain and range of f of x. So what we're going to do here is first things first. Remember, the easiest thing to get initially is the y-intercept, which is this thing. So remember, all you have to do to get the y-intercept is to oh, camera's kind of messing up here. Okay, sorry about that. So the best way to get the y-intercept is just to look at the last number. So again, the y-intercept, we just say that that is 6. Okay, we just say that's 6 there. And next we want to find our axis of symmetry. Now again, remember the way that we get our axis of symmetry. Oh, let's put our y-intercept on our graph. So actually you notice the hash marks here are kind of close. So what I like to do is kind of just go 2 and then make that a number. Okay, so remember that our axis of symmetry, the way we get that is we say x, because x equal to a number will be a line, is going to be the middle number, 5, and remember we got to put a negative in front of that always, over 2 times, well, there's no number in front of x squared, and that's 1. Okay, so then that's fairly easy because 2 times 1 is just 2, and this can be negative 5 over 2, which is about negative 2.5. So that means our axis of symmetry will run through 2.5, and let's go ahead and mark some lines here. So that's going to be negative 1, negative 2, negative 3, negative 4, and then kind of that looks good for here. So 2.5 is going to be about between negative 2 and negative 3. So about right between 2 and 3. So that's going to be our axis of symmetry line there. Okay, so then what we want to do is say, well, let's plug in negative 2.5 into the function to get our y of the vertex. So for vertex, we already know that the x is going to be negative 2.5. And for the y, let's just plug it in. So we say f of negative 2.5 is equal to negative 2.5 squared plus 5 times negative 2.5 plus 6. And we can just enter that into our calculators, and that's going to give us the fraction will be negative 1/4, but the fraction or the decimal will be negative 0.25. So I'll put the decimal up here since we did the x value in decimals. Okay, so what does that mean? Well, that means that our vertex is going to be at negative 2, which we already have the x along this line. And the y of the vertex will be between, and I'll create some hashes here. So it's not going to be about half, it'll be about half of the half. So like right in that space there. So I'll put it right there. And again, I didn't finish drawing my y-intercept either, did I? So let me keep going. So again, my y-intercept is 6, so I know it's going to go through this point. So again, I have to kind of connect the dots here. I have to make sure that from my vertex I get to my y-intercept. So I go like that. And then across the line of symmetry, I create a symmetrical line. So that is my graph. Okay, let's talk about solving quadratic equations. So with solving quadratic equations, there's a few ways we can do that, but first let's talk about what a quadratic equation is in the first place. So quadratic equation is much like a quadratic function that we saw yesterday. All we're really saying here is we're saying a quadratic equation is an equation that looks like ax squared plus bx plus c is equal to 0 where a does not equal to 0. So the a, you actually have to have a be some value, or else it would just be bx plus c, which would just be a linear equation. And that's not what we want. So we're going to learn how to solve this, or basically all that means is that we're finding the x values of this function that make this equation equal to 0. Okay, so we want to know where the x values are that would make it equal to 0. And why would we want to do that? Well, as we'll still see later when we're graphing this out and looking at this a bit more in depth, it helps us to, one, graph it out, two, and define the zeros or the roots of the function, which will actually be pretty important in real-world applications. Now I want to review something that seems kind of obvious, and that's something that we call the zero product property. Now this is something that you're going to see and be like, well, yeah, Mr. Locke, that makes complete sense. Duh, why do we need to talk about this? But this actually, in short, is ZPP. This actually becomes pretty important for us to remember, especially when we're dealing with quadratic equations, to see how to solve them. So this basically, all the zero product property says is that if I have two numbers, a and b, and multiplying those two numbers together gives us 0, so they equal 0, well, that has to mean one of two things. Either a is equal to 0, or b is equal to 0, right? So if I'm multiplying two numbers together, a and b, and that gives us 0, it has to be the case that a is equal to 0 or b is equal to 0. Now, for some of you, again, that just might be completely obvious, right? Like, duh, Mr. Locke, yeah, like, obviously, if I said anything, if two numbers multiplied together equals 0, then one of them has to be equal 0, right? That makes complete sense. But let's see how that's going to help us with our quadratic equations, how to solve them. So we're going to learn about three methods to solve quadratic equations. The first one is called factoring. Again, we've done factoring before with an equation, but let's see what's going on here. Now, in order for factoring to work, it has to be the case equal to 0. So in order for you to factor something, you have to have this equation equal to 0. So let's look at this. So let's solve the following quadratic equations using factoring. So we have x squared minus 8x is equal to negative 12. So what's going to happen here? Well, first of all, again, we notice this is not equal to 0. So we want to fix that. Let's go ahead and add 12 to both sides. So that's going to cancel. We get that x squared minus 8x plus 12 is equal to 0. And now we can continue factoring because it is equal to 0. Okay, so the next thing we want to do is, I kind of like to use a little trick to factor this. I like to create an x, like a big kind of x to kind of organize my thoughts here. And at the top I'll draw the number here, the 12. And in the middle I'll actually put the negative 8, which is the number in front of the x. And I kind of play a game here, and I say, okay, what are two numbers that will multiply to 12 but add to negative 8, right? So which one of, how does that happen? Well, 12, let's see, 6 and 2 multiplies to 12, and if I add those two, it adds to 8, but we want negative 8. But maybe that's a good starting point. So let's write those down. All right, well, obviously, again, these do multiply to 12, but they add to negative. They don't add to negative 8, they add to just regular old 8. What if I make one negative? Well, that kind of throws the whole thing off, because then 6 times negative 2 is negative 12, and 6 minus 2 is 4, which, but you say, what if I make both negative? Well, two negatives multiplied together gives us the positive 12, and negative 6 minus 2 is negative 8, so that works. So that means, why is that helpful? Because this is going to split into x minus 2, x minus 6 is equal to 0. So that splits this 2 into these two factors. And why did we want to do that? Well, because now all I have to do is use my zero product property. And again, it states that if I multiply two things together and they equal 0, one or the other or both have to be equal to 0. So here I'm said that x minus 2 times x minus 6 is equal to 0. So it has to be the case that either x minus 2 is equal to 0 or x minus 6 is equal to 0. Either one has to be the case. Alright, so I want the x value that would make this equation 0. So I just add 2 to both sides here. So that's our first solution. The first x that would give us 0 in this equation is x is equal to 2. And over here I add 6 to both sides, and that's going to give us that x is equal to 6. So what that means here is that these two equations, if I plug them into this equation, or these two solutions, these x equals 2 and x equals 6, will give us this is equal to 0. So actually, let's test that out. I can actually plug it in. Let's plug it into the one that is equal to 0. So we can say that 2 squared minus 8 times 2 plus 12. 2 squared is 4. 8 times 2 is 16 plus 12. 4 minus 16 is, of course, negative 12. And if I add 12 to negative 12, hey, that just gets us 0. So that works. My dog likes that a lot. Okay, so let me show you two other ways that we can factor quadratic equations. So another way we can do this is actually factoring numbers out. So one thing we need to notice in, let's look at number 2. So one thing we need to notice is that a is not equal to 1. And I want to emphasize that's important because I can't immediately use that x method to factor this if this a is not equal to 1. So that sucks. But what I can do is say, well, I notice that 6, 12, and 18 are all common multiples of 6. So what I can do here is, why don't I take the 6 and factor it out of the whole equation on the left. So factoring out a 6, or pulling it out of this equation, well, that's going to make the first term just x squared. The middle term, because I've pulled out a 6, well, that negative 12 gets reduced by a factor of 6 and just becomes 2x. And negative 18, again, reduced by a factor of 6, that just becomes minus 3 at the end there. Okay, so now when I've done that, I can go ahead and now I've made the a in front of this x squared just 1. There's a 6 outside, but again, we're just concerned with the stuff inside. And what I can do now is use that x method again to factor this. So I say, okay, put the negative 3 up here, put the negative 2 down there. And I think, okay, what two numbers would multiply to negative 3 and add to negative 2? Well, the thing there is that there's only two numbers that multiply to 3. 3 and 1, because 3 is, of course, prime. And how can I make those add to negative 2? Well, if I make the 3 negative and the 1 positive, that will add to negative 2 and give us a negative 3. So that works. So that means this factors into x plus 1. X minus 3 is equal to 0. And what that tells us again is that it's either going to be the case that x plus 1 is equal to 0 or x minus 3 is equal to 0. So either one of these could happen. Again, we could say, well, what about 6 equal to 0? Well, yeah, 6 can't be 0, so that's not a solution. We toss that 1 on the other side by subtracting 1, so that's going to give us that x is equal to negative 1. And here we add 3 to both sides. That's going to give us that x is equal to 3. Cool. So either one of those we can plug into this and it will give us 0. So the last one we're going to learn about is kind of an interesting one. It's probably the most trick math oriented that I get. But it's really interesting. So here, this is number 3. We see 2x squared plus 11x plus 12 is equal to 0. So what I notice is, well, why don't I pull out the 2 out of the equation? Well, the reason is because 11 is not a multiple of 2. I can't take any number out of both 2 and 11. There's no number I can divide that's divisible by 11 and 2, right? That's impossible. 12 would work, but 11 does not. So what I'm going to do is I'm going to use this little trick I learned. And this trick involves an acronym called My Father Drives a Red Mustang. Interesting. What does that mean? My father drives a red Mustang. Well, we use the first letters of all of these to represent certain operations that we're going to do to this quadratic equation to solve it. So let me show you guys. So what I'd like to do is kind of create a little table of 5 rows. And what we're going to do is each of these letters for My Father Drives a Red Mustang is going to get placed in each of these on the left. So we're going to say My Father Drives, and I like to put a drives a red Mustang. Alright, so what in the world am I talking about here, right? My dad drives a red truck, right? He doesn't drive a red Mustang. Well, let me show you guys. So what I'm going to do, the M tells us, the M stands for move. So what we're going to do is we're going to move the number in front of the 2x squared and multiply it by the 12. So what we're going to get is we're going to say that x squared, so again we've moved this 2, nothing happens to the 11x, but now the 12 gets multiplied by that 2 that's in front of the x squared, and that's actually going to be 24. Okay. F, that means to factor. So now we want to factor this new equation that we got, and we notice there's no longer a term, a 1 in front of the x squared, so we're actually going to factor that using our x method here. And can you think of 2 numbers that multiply to 24 that add to 11? Yeah, sure. I think 8 and 3 do that. So this is going to factor in x plus 8, x plus 3. Divide, so drives, dA, that means we're going to take the numbers 8 and 3, so the numbers in this spot right here, we're going to divide them by the a form, which was in our original equation. So we're going to say x plus, so we're going to say 8 divided by 2. And over here, we're going to take the 3 and divide it by 2 as well. Cool. Let me zoom in a little bit here. Zoom out. There we go. Okay, so next what we're going to do is we're then going to reduce. The R, the red, means to reduce. So 8 over 2, well, 8 over 2 is just 4. And then 3 over 2, well, I can't reduce that, so I'm just going to leave that as 3 over 2. And then the last M, we're again going to move the number in the bottom of the numbers inside of the parentheses to the front of the x again, right? Because we moved the 2 to this number, but now we got to put it back. So here, well, it's just 4, and we can think about it as 4 over 1, so we can't do anything with that. We'll just leave it as 4x plus 4. And here, what we're going to do is take that 2 in the bottom, and we're going to move it in front of the x, and that makes it x plus 3. And there we have now factored our equation. That's kind of a neat little trick, isn't it? So now that I've factored this, I can then use my zero product property to say, okay, well, x plus 4 must equal 0, or 2x plus 3 must equal to 0. Right? And so the first one's easy. We just subtract 4 on both sides. That gives us x has to be negative 4. Or Well, 2x plus 3 is equal to 0. So with this one, we got to do a little bit more because we have that 2 in front of the x, but not too much. We just subtract by 3. That's going to give us that 2x is equal to negative 3. And then we want to get rid of the 2 in front of the x, so we divide by 2. So that gives us x is negative 3 over 2. Cool. So that was kind of a neat little way of doing that we solved that. Alright, so what I want you guys now to do is just do 4, 5, and 6. Again, these follow pretty much from the ones that we just did. Factoring out a common factor, the greatest common factor, and then using that weird little trick I just showed you. So give those a shot, pause the video, try it out, and come back and we'll talk about it. Alright, so let's go ahead and run through these 3 problems. So what we're going to do here is, let me make this all nice and neat for you. Okay, so what we're going to do here is let's go ahead and take on number 4. Let me zoom in so we can kind of focus on that one here. So what we're going to do here is let's go ahead and add 36 to both sides first, because again, in order to factor something, we want it to be equal to 0. So we're going to get m squared plus 12m is equal to, or sorry, not equal to, my apologies. We're going to add 36 because the right side is now equal to 0. Man, I'm just flubbing all over the place today. So again, the number in front of m squared is 1. So let's give basic factoring a shot. Let's think about 2 numbers that multiply to 36 but add to 12. Well, the 2 basic ones, the first ones that came to mind for me are 6 and 6, and in fact those 2 do add to 12. So this will factor into m plus 6. m plus 6 is equal to 0. And so notice I could set both of these equal to 0, but I really don't have to because we're going to get the same thing because they're both m plus 6. So let's just say m plus 6 is equal to 0 here. And I subtract 6 on both sides to get that m is going to be equal to negative 6. And again, this is a case where actually our quadratic equation is just going to have the one solution of m minus 6. So that's kind of interesting, right? Okay, let's look at number 5 here. Let's look at number 5. Okay, so number 5, again, we notice that we have a number in front of our x squared term, and that's kind of a problem. Because again, in order to use this method over here, we only had to have 1 in front of the squared term. So here what we're going to want to do is let's factor out a 5. Because we notice 15 and 50 are both factors of 5. So take out a 5, that just gives x squared on the first term. 15, well, if I reduce that by a factor of 5, that's going to give me 3x. And if I reduce 50 by a factor of 5, well, 50 divided by 5 is just 10. So that goes on the end. All that stuff still equal to 0. Okay, so now what we're going to do is we're going to say, okay, well, just factor this as usual. So negative 10 and negative 3. What 2 things multiply to negative 10 and negative 3? Well, let's think. Well, 5 and 2, right? So that works. But again, it seems like that doesn't really add to 3. It adds to 7. But what I can do is think, okay, but what if I make one of these negative? Because again, it has to multiply to negative 10, so 1 does have to be negative. Well, if I make the 2 negative, that's just going to be 5 minus 2, which is positive 3. So I'm going to want to make that 5 negative. And so that will factor into x plus 2. X minus 5 is equal to 0. And so one little trick I didn't show you guys, but if you have just x plus 2 and x minus 5, so there's no number in front of the x's, you can just kind of flip the signs here and say that that is the answer. So again, x plus 2, that's going to be x minus 2 and x plus 5. And if you want to go through that whole x equals or zeros thing, that also works too. But those two are our answers. All right, let's go ahead and look at number 6 here. Kind of like the zoom in thing. That was kind of cool, wasn't it? Zoom in a little bit. Little bit. Okay, so what we're going to do now is factor this. Now again, this one we have a 4 in front, and 21 and 18 don't have any common factors or with 4. So what we're going to do is that my father drives a red Mustang trick. So I'm going to create my little table here. My little table. My father drives a red Mustang. And again, let's go through the whole spiel. So what we're going to do is say, okay, well, we move the m, first m, is we move the 4 to the 18. We multiply the 18 times the 4. So we're going to say 8x squared plus 21x. 18 times 4. Feel free to use a calculator for that. That's going to be negative 72. F factor, so we're going to break it down into 2 factors. 72, that's actually going to break down into negative 72 and 21. So that's a tricky one, right? What two numbers can multiply to give us 72 and 21? Well, if I add 7 and 2, that's 9. So I know that this is divisible by 3. So maybe I should try that. And what about 24? Well, 72 divided by 3 is in fact 24. Now again, 24 plus 3 is 27, which is not 21. But one of these has to be negative anyway, because we need negative 72. So we'll make the 3 negative, and of course 24 minus 3 is 21. So those are our factors. Okay, so now what we'll do is dA, divide by A, drives A. So we take that number, 24, and we're going to divide it by the A that was in the original equation. So we say 24 divided by 4. And then we also say 3 divided by 4. Okay, so the R tells us to reduce. So we're going to want to reduce whatever fractions we have here. So here, 24 reduced, well 24 reduced, 24 divided by 4 is actually just 6. And I can't reduce 3/4, so we'll just leave that as is. And then m, we move back. We move back whatever's in the bottom in the denominator of the number, and we put it in front of the x. So here, well, there's not really a number in the bottom of 6, except, 1. So we'll just leave that as x plus 6. And we see that 4 in the bottom here, so we'll move that in front of the x. So it'll be 4x minus 3. So again, remember, this is still equal to 0. So we've now factored this, and that's going to give us that x plus 6 is equal to 0. So the first thing, or 4x minus 3 is equal to 0. That's 2 options. This one, subtract 6 on both sides. X is just equal to plain old negative 6. And 4x minus 3, let's go ahead and add 3 to both sides. So that's going to give us 4x. Got to do a little bit more work, but it's not too bad. X is equal to 3 over 4. Those are our 2 answers. Okay, so making these, this is taking longer than I thought it would. So let's go ahead and stop there, and we'll pick up from there method 2 once we take our unit exam after the 6 weeks ended, and we've gotten into the next 6 weeks. We'll talk about completing the square and the quadratic formula, which are actually 2 pretty interesting things when we're talking about quadratic equations. So we'll stop there. Go ahead and show me this part of your notes for a daily grade, and we'll pick it up after next week after our unit exam. So I'll go see you guys next time.